Andrej Karpathy just gave a keynote on AI and the future of software. And honestly, I haven't felt this inspired about technology since 2 hours ago when I was vibe coding my songwriting AI project. He's talking about coding with natural language, building full apps without touching a keyboard, and a future where anyone, I mean anyone, can create software just by explaining what they want. And it's not hype, it's here. It's happening in real time. And I couldn't not bring it to you. So if you ever felt like the tech world was moving too fast to catch up, this is your on-ramp. Let's talk Software 3.0. Hey everybody, welcome back to Wonderkind, the show where we dive deep into the wild frontier of creativity, technology, and human potential. I'm Jonathan Schwartz, your host, and today I just saw one of the best talks I've ever seen on the future of software, AI, and honestly, what it means to be a doer, a builder, creator today. This talk is by none other than Andrej Karpathy, one of the clearest, most forward-thinking voices in AI. You might know him from Tesla, OpenAI, or maybe you've read his blog, but in this recent keynote, he delivers what I can only describe as a lightning bolt of clarity on where we are right now with AI and where we're headed next. It's called Software is Changing, parentheses again. And folks, it's not just for engineers or AI nerds. This is for anyone who's curious, creative, and bold enough to step into the future. If you've ever wondered, can I really build with AI? Am I technical enough? Is this just for software engineers or pros? This talk flips that script. It's empowering, it's accessible, and it left me fired up. So here's what we're doing today. I'm going to break down the big takeaways from Karpathy's talk, translate the technical bits into plain English, just like he's talking about with using English to code, because this world is evolving fast and we are here to keep up. Honestly, I recommend you just pause right now and watch the talk yourself. I will drop the link wherever you're listening, but if you're on a walk, driving, folding laundry, let's get into it, because Software 3.0 is here and the revolution might just start with your next idea. Let's start with the foundation, because Karpathy breaks down software into 3 distinct eras, and understanding this progression is key to grasping why we're at such a pivotal moment right now. So Software 1.0 was the age of explicit instructions. Think back to traditional programming, the last 70 years. This is where we picture what we think of coding. You sit down, you write lines of code in Python, like my dad just tried out for the first time last week using ChatGPT, and you're giving the computer extremely specific instructions, like step by step, do this, then this, then this. It's like writing a recipe where you have to specify everything. Heat the pan to exactly 350 degrees, add 2.5 tablespoons of oil, wait exactly 30 seconds, add the onions, stir clockwise 4 times. There it is. This is powerful, precise, but it's also exhausting. And it requires years of learning these languages, understanding syntax, debugging when you miss a semicolon. We've been through this era for 70 years, and it's produced incredible things. The internet, smartphones, everything digital around us. Now, we move on to Software 2.0, the machine learning revolution. This is where Karpathy gets really interesting, and I apologize for butchering his name every time. A few years back, he actually coined the term Software 2.0 to describe neural networks and machine learning. Instead of writing explicit rules, you feed a computer tons of data and let it learn the patterns itself. Think about a spam filter. Okay, so in Software 1.0, you'd write the rules. If the email contains the word lottery and urgent and comes from a suspicious domain, mark it as spam. But in Software 2.0, you feed the system thousands of emails labeled spam or not spam, and it figures out the patterns itself. This code is now embedded in the weights and connections of a neural network, which is modeled after the brain. This revolutionized everything from image recognition to recommendation algorithms. But here's the thing, it still required machine learning experts, data scientists, people who understood how to train these models. Software 3.0. Now we move into programming in English, and that's where we are right now. We get into this mind-blowing part. Karpathy argues that we are now in Software 3.0, where your prompts are your programs. You describe what you want in plain English, and a large language model like GPT-4, Claude, and others generates the code for you. Let me give you an example, okay? Instead of spending weeks learning React and JavaScript to build a to-do app, which is a basic first app for engineers, you could literally say, Build me a to-do app with a dark mode toggle, the ability to set priorities of those to-dos, and integrate with Google Calendar. And the AI will generate a working prototype in minutes. Now, there's a little bit of setup with the Google API, and Karpathy gets into those extra steps as well. But this isn't theoretical. This is happening right now to get to that prototype phase. GitHub Copilot is already helping millions of developers write code faster. There are other tools like Cursor and Windsurf that I use daily that are letting people build entire applications through conversation. And there are tools where you can do voice to speech, like a tool by Y Combinator called Aqua, that you just literally record your voice and it goes straight into those tools. Think about that. The language you're using to listen to the podcast, this is how we program computers. So the barrier to entry is zero. It's at the floor. As he puts it, remarkably, we're now programming computers in English. So it's all in our hands. Now we're onto the vibe coding revolution. Karpathy had introduced the concept called vibe coding, which you've probably heard. It's been a meme. Rick Rubin, one of my favorite thought leaders, had a picture of himself and even vibe coded his own book based on an ancient Chinese text. But it is, if you haven't heard the term, it's exactly what it sounds like. Instead of meticulously planning out every function and class and variable and semicolon, you just describe the vibe of what you want. You tell the AI, I want a cozy minimalist journaling app with a vintage aesthetic and smooth animations. And it builds that to the best of its ability. Sometimes you have to take one shot and try it again. If you don't love it, a little bit like pulling a lottery or a slot machine, but you get the best you can. Karpathy demonstrated this with his own project called MenuGen. He had a relatable problem. When you're at a restaurant and you see something like tagine and sweetbreads on the menu, but you have no idea what it looks like, or in my case, you have no idea how that's even pronounced. So he thought, what if I could just take a picture of the menu and see the images of all the dishes? So he vibe coded this entire app. He hadn't worked in Swift before, which is a programming language for the phone, and just in a couple hours, he was able to see a working prototype. The front end, the back end, the image generation logic, everything. He wrote zero of the code himself. Now, he was honest about this. The vibe coding part, it was exhilarating. He had a working demo in hours, but then he had about a week of additional work that he had to set up authentication, configure payments. He deployed it to the cloud. He got a domain name. He managed the API keys, handling user data. So it was quite a bit of extra effort, a lot of clicking, which is one of the things that Karpathy says will be removed from this future world. We won't want to have humans clicking at all in the new paradigm. We just want curl requests and other ways that the AI can communicate and do things fully on behalf of the humans coming up with these ideas. So a lot of setup, a lot of instructions. He spent, as Karpathy puts it, I spent most of the time in the browser moving between tabs and settings and configuring and gluing a monster. How are we supposed to be automating society by 2027 like this? And I agree. He did ship the program at menugen.app if you want to take a picture of your specific menu and see what this is really like. It's a working app built by someone who obviously is one of the smartest brains in AI generally, but he didn't know how to code that specific way. So what he demonstrated there is that the traditional barriers to software creation are crumbling. You do not need years of computer science education. You don't need a deep knowledge of frameworks and libraries, understanding of deployment pipelines. You don't need an expertise in database and APIs. You need curiosity, persistence, and the ability to describe what you want clearly and cleanly. Think about these implications. How many problems could be solved by people who understand the domain, but not the code? Teachers could build educational tools. Small business owners could create custom solutions. The democratization potential here is staggering. I just heard Sam Altman talk on my college friend's Jack Altman, his brother's podcast, about physics being one opportunity for discovery because they just haven't had enough bandwidth in certain areas of the science to go through a mountain of data. So there's many industries where just having these ideas and freeing up bandwidth to actually execute on ideas is going to be an incredible opportunity for society. So the next part Karpathy goes through is the LLMs as our new operating system. So the large language models aren't just tools or applications to Karpathy. They're becoming something much more fundamental, the new operating system for how we interact with computers. The analogy is an operating system does basically what Windows, Mac, Linux do. They manage your computer's resources, they run programs, they provide interfaces, handle memory and storage. They're the foundation with which everything else is run upon. Karpathy argues that LLMs are becoming similar foundational layers, but for intelligence and reasoning. Instead of clicking through menus and typing commands, you converse with your computer. You describe what you want to accomplish, and the AI figures out how to orchestrate the various tools and services that it needs to make that a reality. It's like having Jarvis from Iron Man, that conversational interface that can control everything and understand context. Now, one of the parallels Karpathy talks about is that we're essentially in the 1960s of AI computing. Back then, computers were huge, expensive machines that lived in data centers. People accessed them through terminals via time sharing. Everyone got a slice of the mainframe's attention. Today's powerful AI models are massive, expensive systems running in the cloud. We all access them through APIs or chat interfaces, sharing the computational resources. Just like how personal computers eventually brought computing power to individuals, we might see personal AI devices in the future. Apple's working on on-device LLMs. Projects like EXO are networking multiple devices together to create local AI clusters. The future might be having your own personal AI assistant that runs on your hardware and serves just you. And there were images in the talk of multiple M4 Mac Minis as stacks, basically creating your own local servers with a ton of memory and compute power that the Apple Silicon chips specifically are really, really well suited for this time. There's another way to think about LLMs, basically as a utility, similar to electricity or water. You don't need to understand how the power grid works to flip a light switch. Similarly, you don't need to understand transformers and neural networks to use ChatGPT. And this is where something unprecedented happened. Usually, new technologies start with governments and big corporations, then trickle down to consumers. Nuclear energy, GPS, the internet, all started as military or industrial products. But with LLMs, the pattern is flipped completely. Consumer adoption came first. ChatGPT reached 100 million users faster than any technology in history. Regular people suddenly had AI assistants on their phones before most companies figured out how to integrate them into their workflows. As Karpathy puts it, the future is already here, and it is shockingly distributed. This isn't locked away in some Pentagon basement. This is in your pocket right now. So let's get real for a minute, because while everything I've shared so far might sound like we're living in a utopian sci-fi future, Karpathy is refreshingly honest about the limitations and the quirks of current AI systems. He uses a perfect metaphor. An LLM is like a dancing bear. The fact that it can dance at all is amazing. You shouldn't focus on how well it dances. These AI systems can write essays, code in dozens of programming languages, solve complex problems, pass professional exams, or in my case, read through hundreds of pages of documentation to apply to a condo board, capabilities that would have seemed magical just a few years ago. But they also make weird, sometimes embarrassing mistakes. And two comparisons here, he has jagged intelligence. They could be superhuman in some areas and surprisingly dumb in others. An AI might write a brilliant analysis of quantum physics, then incorrectly tell you that 9.11 is greater than 9.9. And he compares this type of brain functioning to Rain Man, the movie with Dustin Hoffman and Tom Cruise. Great film. Unlike humans, whose abilities tend to improve together, AI systems have this spiky, unpredictable capability profile. You never know if your question will hit one of their smart zones or their blind spots. And so he often talks about needing to keep AI on a leash and have a good monitoring system in place so that we can kind of feel that out and make sure it doesn't go in a vision quest, as he calls it. Another piece is the memory problem. A crucial limitation is LLMs suffer from what Karpathy calls anterograde amnesia. They can't form new long-term memories. And the examples he uses the movies 50 First Dates with Drew Barrymore and Adam Sandler and Memento. Each conversation starts fresh. They cannot learn from experience the way that humans do. It's like working with a colleague who forgets everything each morning. Imagine if every day you had to re-explain your company's processes, your preferences, the context of ongoing projects. That's what it's like working with current AI systems. And personally, I've had to implement specific language and instructions at the top of each conversation I have with Claude in a very hyper-compressed way to say, here's exactly what you need to do when you run out of memory. At 75%, I'm going to need you to warn me and tell me a compressed version of everything we talked about in this chat. Then at 90%, you need to shut down and not answer anything, because if you get locked out of that memory at the end of a session, you're screwed. And you won't be able to carry that information to the next conversation unless you do a lot of copying and pasting, and then it becomes a wall of text that's not helpful too. So there's a lot of issues around this, and you really need to be careful about the memory problem. Understanding these limitations isn't about being pessimistic, it's about being realistic and strategic. You need to know where the AI excels. Pattern recognition, rapid prototyping, broad knowledge synthesis, for example, and where it struggles. Consistency, memory, self-awareness to use it effectively. This is why he emphasizes keeping humans in the loop. AI is an incredibly powerful assistant, but you're still the CEO of the process. You provide judgment, oversight, and the final decision on what's good. Now we want to talk about one of the most practical insights from Karpathy's talk, the idea of the autonomy slider. It's a framework for thinking about how much independence you give AI in different contexts. So Karpathy uses the Iron Man suit as the perfect analogy. So sometimes Tony Stark is in full control of the suit. It's pure augmentation, making him stronger and more capable. Other times, the suit operates autonomously. Jarvis takes over to protect Tony or handle routine tasks. The key insight isn't that it's binary. It's a slider that you can adjust based on your situation, your comfort level, and the stakes involved. So a couple examples. In the coding tools like Cursor, Windsurf, low autonomy, AI suggests single lines of code you can accept or reject. Middle autonomy, middle slider, AI writes entire functions based on your description. High autonomy, AI modifies multiple files and implements complex features end to end. And you get to choose where that goes on the sliders. And it defaults pretty conservatively. So you need to really, at least in my experience, be pretty heavy-handed in saying, I don't even want you to ask for permission on this, just do it. I've said just do it quite a few times pretty loudly to Windsurf and Cursor. And in tools like Perplexity, low autonomy means AI answers specific questions with sources. Medium autonomy, AI performs multiple step research across several sources. High autonomy, they go conduct deep research projects and write comprehensive reports. And in self-driving cars, we already have that. Level 1 is basic driver assistance. You may see that. My parents have it on their Subaru. Level 4 is full autonomy in most conditions, like Waymo. The generation verification loop is the next piece here. That's where the magic happens. The AI generates proposal, code, text, and actions, and the humans verify them quickly. The faster this loop, the more productive the collaboration. And this is why good AI tools focus heavily on making verification easy. Instead of reading walls of text, you see visual diffs, color-coded changes, clear before and after comparisons. And I love while it's thinking, just giving me the process so I can make sure I understand the directions it's going and steer it as necessary. Your brain's visual processing system is much faster than reading, so good interfaces, good visual input leverages that. Karpathy learned a lesson painfully at Tesla with autopilot around partial autonomy. A completely autonomous demo can look perfect, but the edge cases, that 1% of situations that the AI really can't handle, matter enormously in the real world, as you can imagine, on the road specifically. A demo just needs to work in one scenario. A real product needs to work reliably in all the expected scenarios. And that's why the most successful AI applications today use partial autonomy with human oversight, not fully autonomous agents running wild. That isn't great right now for production code. Here's what gets me most excited about Software 3.0. It's fundamentally inclusive. For the first time in computing history, you don't need to be a technical person to create software. My dad is creating software programs, very small lines of code with Python, but he's using AI to help him debug, to put in different errors that he's seeing. He's learning about libraries. This would not have happened in any scenario if we did not have these tools. Suddenly, everyone is potentially a programmer. Teachers, designers, small business owners, artists, parents, Reiki teachers. Anyone with ideas and the ability to articulate them can now build. Karpathy points out something remarkable. LLMs make individuals disproportionately more powerful. Educators are creating custom learning tools for their students. Artists are building interactive experiences without learning to code. Karpathy showed a really cute video of kids doing a vibe coding exercise together, and that's the future of society. The democratization is real, and it's happening now. The most beautiful aspects of this revolution is how welcoming the community is. Platforms like Hugging Face, and their motto is AI for everyone, with a Hugging Face emoji, hosts free courses and forums. I use them quite a bit to do a deep learning course with Fast.ai that I highly recommend. Y Combinator is funding diverse founders building AI for Y Combinator is like the ChatGPT and local llama communities are welcoming to beginners. Discord servers are popping off with people sharing experiments. Kaggle is a great community that I've been looking into applying for some of the different competitions around deep learning and some really interesting topics there. The energy reminds me, Karpathy, everyone who's involved, of the early internet or the maker movements. It reminds me a little bit of early Kickstarter. People are really excited to share, teach, and build together. So as more AI agents enter the digital world, our software infrastructure needs to evolve to accommodate them. This creates fascinating opportunities for our builders. Karpathy shares some brilliant examples of what AI-first design looks like. Documentation revolution. Instead of writing docs for humans with screenshots, bullet points, visual formatting, services are creating AI-readable versions. Stripe and Vercel are early movers here. They're providing their documentation in clean markdown files that LLMs can easily parse and understand. Just like websites have robots.txt files to instruct web crawlers, we might see LLM.txt files that tell AI agents what a domain is about and how to interact with it. When docs say, click this button, that's useless to an AI. Forward-thinking companies are replacing every click event instruction with equivalent API calls or command line instructions that agents can actually execute. Some of my favorite examples of AI-first tooling: Git ingest. You change a GitHub URL from github.com to gitingest.com, and it concatenates all of those code files into one giant text file that's perfect for feeding into an LLM. DeepWiki. It takes GitHub repos and has AI analyze them to create comprehensive documentation, essentially letting AI explain code to other AIs. Like the early internet, the PC revolution, or mobile computing, moments when the tools change so fundamentally that new possibilities emerge. The difference this time, the barrier to entry is lower than it's ever been. You need curiosity, persistence, a few $20 a month subscriptions, and ideas. Pick a simple project, maybe a personal website, a tool for your hobby, something to solve a tiny problem in your life. Use tools like ChatGPT, Claude, or Cursor to help you build it. And you'll learn by doing. Even if it's a bunch of copy-paste over to a certain area and you say, I don't know what I'm doing, just ask GPT. Give it the screenshots. Work your way through the process. And if you're more advanced, comparison shop. When you're waiting for Claude to finish something or Cursor, you go over to Windsurf. Make these tools dance with each other and kind of riff in a jazz-like way. Learn prompt engineering. Treat this as a mandatory skill for the new world. There are great free resources on effective prompting. Start simple and layer in more structure. Notice how different phrasings change AI's behavior. Join the community. Follow researchers and practitioners on Twitter. Follow Andrej Karpathy on X and watch some YouTube videos by folks from Fast.ai or other great resources here. Everyone is figuring this out together, and the more you share, the more others will share back. Think about impact. As you experiment, consider how your tools could help others. The most exciting applications might come from domain experts, teachers, doctors, scientists, artists, who understand the problems that pure technologists may miss. Now, with great power comes great responsibility. As you build with AI, think about inclusivity, bias, accessibility. Stay curious and think about the societal implications. Even Sam Altman said, I don't know what's going to happen to society, even though the technology is more powerful than I could have even imagined at this point. When I watched Karpathy's talk, what struck me wasn't just the technical insights. It was the sense of invitation, possibility, and conceptualizing this shift to things everybody understands, like electricity, the power grid. Things that were once available to technical elites are now accessible to anyone with ideas, determination, and decent Wi-Fi. This is your invitation to step into the future. Whether you're a student, a parent, an empty nester, an artist, an entrepreneur, or just someone who's curious, the door is open. And it's only going to get better from here. I genuinely believe that we're at the beginning of a new renaissance of creativity and innovation. Regardless of age, regardless of gender, regardless of your background. The question isn't whether this future will arrive. It's already here. The question is whether you will be part of building it. So here's my challenge to you. Use the AI tools available today. Start a conversation with GPT, Claude. See what happens. You might surprise yourself with what you can create. I'll drop links to Karpathy's original talk, some of the tools we discussed, and resources for getting started in the show notes. Please tag me. I'd love to see what you create. Until next time, keep wondering, keep building, and remember, the future is not something that happens to you. It happens for you. Thanks for listening to Wonderkind. I'm your host, Jonathan Schwartz, and I'll see you in the next one. Bye-bye.